students, welcome to Ask IITians. How are you all? I hope you all are doing very well. You all are good. So students, we are going to start new chapter, that is the metals and non-metals. So what the thing is that I was thinking to introduce myself. So should I introduce? Okay, so my name is Arushi Sharma and I'm going to teach you chapter that is the metals and non-metals. So after listening the word, like after listening the name of the chapter, so what do you think about the metals and non-metals? Do you have any idea about them? So generally when I ask this question to student that okay what is metal, so they generally give the answer that ma'am metal is something which is having shiny structure or which are malleable or ductile. Okay, but today we'll see that what exactly the metal is and what the non-metal is. Fine, so we are going to see all of these things in this chapter. So now we are going to start with this chapter. Okay. Actually, one thing is there which I want to tell you, and it is also very important. Like, why it is important? When you are going to your class 10th, that means you are going to give your board examination. Exactly. And you will be getting a whole chapter related to metals and non-metals in chemistry. Okay. That's why, student, it would be a good thing for you that if you're learning the basic, what I can say, basic thing about the metals and non-metals. So it will be a great help for you when you are going to class 10th. That means you are covering up, I can say 30%, or even though I will try to cover up the 40% of your class 10th in this only. Not exactly 40 is more, but I can say 20, 30 we are going to cover up if we compare it to the class 10th. Okay, so now what are the topics we are going to cover up in today's session? So we are going to covering up the introduction. Okay, like what's the metals, non-metals, and why we require them, classification into the metals and non-metals, physical properties of metals and non-metals we are going to discuss. Then we'll see that what are the exceptions for both metals and non-metals. See, exceptions are there. Now why we are going to study all of these exceptions? Because it's the important part. Why it is important, students? Because the MCQs question for the competitive exams generally comes from the exception part of the metals and non-metals. So it's the important part, just to, so that's why what I can suggest to you that please watch this session carefully because it is going to help you a lot. Okay, so now starting with the introduction. See, student, that if we look around us, so what the thing, student, that everything if we talk about, so we have categorized them into the metals or the non-metals. So it's become a very important thing for us so that we can distinguish it. Like how can we distinguish them? For example, student, that this is the plastic. Now plastic is made up of some non-metals. If I say iron, like iron box, so iron box is the metal, we know this. Okay, it is the metal, it is the non-metals. But how can we distinguish them? On what basis we are saying that they are metals or the non-metals? So we are going to see all such things. For example, student, what happened generally, like if I talk about for in the past, like some years ago when the development was not there, so people used to make a wooden bridge they use. But what happened that the wooden bridge are not last longing, like they just the wood is like when there is the rainfall, so wood is getting damaged, so that's how the bridge was not last longing. So that's how student people start thinking that they should use some kind of material that it would be stronger in nature and the bridges will be long last, like they are not going to be we can say they are not easily going to be destroyed. Fine, so that's how they start building the bridges of metals like steel, iron, zinc. So they are using all such metals in that condition. So that's how student we have seen that okay how the metals are used up and where the non-metals are used up. So we have to see all such things, and now we are going to discuss all about metals and non-metals only. Okay, so now first of all we are going to talk about metals, that what exactly we can say the metal is. So students, as I've told you that generally students say that metal is something which is shiny in nature, or we can say which is malleable or ductile. See student, all these are the properties of metal. But if we talk about metal, so what the metal is exactly, student? So metals are described as chemical elements that readily lose the valence electron to form the positive ion, that is the cation. Example: aluminium, copper, iron, tin, and gold. That means, student, we are talking about metal. So metal is something who is losing their electron very easily and forming the positive ion, that is the cation. So we call them as the metals. So students, if you have seen the periodic table, so in the periodic table we are having groups like group 1 and group 2. So in that, metals which are present, so they are called as the metals. Fine. Now in the group 1 there is the sodium, that is the Na is sodium. Fine, students. Now what happened, that the atomic number, if we talk about the atomic number of sodium, so it is 11. Fine. Now as I can say, if you know about the electronic configuration, so what happens, student, that if we talk about neon, that is the neon, neon. So it is a noble gas. Fine. And the noble gases in all of the periodic table, and we can say among all of the elements, they are very, very stable. Like they are very less reactive, or you can say that they don't react. So the neon is having the atomic number of 10. Fine. If I do the configuration for the neon, so it would be 2 for the K, 8 would be L. Okay, so you can see that this is the configuration of neon. Now what's the valence electron is? So the valence electrons are those electrons which are present in the outermost shell. Outermost shell, that is the electrons in outermost shell are called as the valence electron. And we know this thing, student, that the metals can lose their valence electron only. So now it is the neon. But if I see for the sodium, so it is the 281 for the K, L, M. Now if we compare the sodium with the neon, so what we have observed, that okay, the noble gas is very stable when its octet is completing at 8. But in this case, if the sodium is going to lose this one electron, so it will also occupying the state of what, 2 and 8. That is just similar to the neon. That means the sodium is also becoming very stable in nature. And that's how, student, every elements try to like they always try to occupy the stable configuration, so that they will be all like they are also stable as their noble gases are. Fine. So that is why the sodium will lose its one electron, and when it is losing its electron and forming the positive cation, that is why, students, metals are called as the electropositive elements. Electropositive elements. That means when there is the sodium, and sodium will lose its one electron, so it will occupy the plus charge and there will be the lose of electron. When there is the lose of the electron, or you can say that by the donation of the electron, when the element is occupying the positive charge, so we call it as the cation and we call it as the electropositive ion. And that's why, student, metals are electropositive in nature, because they lose their valence electron to form the positive ion, and that positive ion, what we call it as cations. That is why, student, metals are, you can say, they are electropositive. Fine. This is about sodium. But as they have given another example, aluminium, copper, iron, tin, gold, so these all are the metals, because they are having the ability to lose the electrons. Okay, so that is how, student, the metals are those chemical elements which are electropositive in nature. That means they can lose their electron, because what happened, that they, just to make a simple configuration, or we can say that just to make a stable configuration as compared to the noble gases, they also lose their electrons, so that they would also become stable in nature. Fine. So I have given you the example of one element metal, that is the sodium. You can take any other example of the metal, like if I here take a example of aluminium. So let's change the color. Okay, yeah, it is also visible. Aluminium. Okay, aluminium is having 13. Now it is 2, 8, 3 for K, L, M. Now if you compare it with neon, so students, what you observe, that it is 8 and it is having these 3 electrons in extra. So aluminium can lose these 3 electrons. That is why aluminium forms the cation, but it will acquire the 3 positive charge, because it is losing the 3 electrons. So students, one positive charge means like one electron has been donated, 3 positive charge, that means 3 electrons has been removed. So when any of the element is losing its valence electron, that means the outer shell electron. So for the sodium, M is the outer shell, and for the aluminium is also M is outer shell. So when it is losing its electron from their outer shell and forming the positive ion, because of the loss what we can say, loss of the electron. So that is called as the metals. And we have seen that what are the examples of the metals. It is aluminium, copper, iron, tin, gold, and many other also. Fine. So now if someone is going to ask you what is metal, so what would be your answer? That metals are those elements which are electropositive in nature because they lose their electron which is present in their outer shell or the valence electron to form the positive ion which we called as the cations. Fine. Good. Okay, now coming to the non-metals, that what are the non-metal students? So we have seen that okay, metals are electropositive in nature, but now if we talk about the non-metals, as you can see here, student, that from 5th to 9th, this is the non-metal, and this is the noble gas. This is a picture of the periodic table, students. Okay, so if we see what are the non-metals, so non-metals are those elements which do not exhibit the properties of metals. So uh, it's a very basic definition. If someone asks you what is metal, so you are going to say that okay, so which do not exhibit the properties of non-metals. As we have seen that the metal is something which is electropositive in nature. So students, non-metals are something which are electronegative in nature. What? Electronegative. Fine. Now how they are electronegative? Because students, as the metals are losing their outer electron, so what the non-metals do? Like they gain electrons. So in the non-metals, what the thing is that they gain electron. Gain of electron is there. How? Okay, so I'll tell you this thing. See, okay, I'll take the example of fluorine. Okay, fluorine. Fluorine is the non-metal and it is represented by F. And its atomic number, if I see, so it is 9 here. Okay, so it is 9. Now, if I do its electronic configuration, so it is K and L, so it would be 2 and 7. Exactly. Now, if I compare this fluorine to its nearest noble gas, that is the neon. Neon, its nearest noble gas, so it is neon. Neon is represented by Ne and its atomic number is 10. And if I see its electronic configuration, so it is Kl and it would be 28. Now if I observe the difference between the fluorine and the neon, what I can see that the fluorine requires one electron to make it 8. Exactly, because students, what happened that there is the some limit to gain the electron and to lose the electron. Fluorine can't lose its 7 electron. It is a very difficult thing to lose the electrons. That is why student, non-metals are those type of elements which gain electrons. Fine. So when you add one electron here, one electron is added here, so it will convert to 8. Now what will happen that fluorine, by gaining the one electron, like you are adding electron into it now, like I am representing the electron. Okay, so don't get confused about it with this E negative sign, because electrons are what? They are negatively charged. So it converts into Fe negative. Okay. Oh, sorry, not Fe. Fe is iron. F negative. That means students, when fluorine is accepting the one electron, so it is converting into the negatively charged species, and these negatively charged species, we call them as the anions, because they carry the negative charge by the acceptance of the electrons. And when they are accepting the electron, and due to the acceptance of that electrons, when they carry the negative charge, that's why they are called as the electronegative ion. Fine. So the metals are losing the electrons, but the non-metals are gaining the electrons, because as we have compared, so what we have observed that they can't lose all the electrons. That is why they are carried, like they are taking one electron from any other element, so that they can so that they can attain the stable configuration. Because students, the noble gases are very stable. So all of the elements in the periodic table wants to meet that requirement, like the noble gases are having. So for that, some of the metal, like some of the elements lose electrons, and then we call them as the metals, and some of the non-metals gain the electrons. So that's how we are having metals and non-metals. Fine. So similar thing is here, students, like fluorine is accepting one electron, so it is having the one negative charge. Okay, but if I talk about oxygen, so take the example of oxygen. Okay, so in oxygen student, I have seen that it is 8. That means Al26. Now compare it with neon. So what you have find out that again 6 electrons can't be loose by the oxygen. So what it will do to attain the stable configuration, it will try to accept the 2 electrons because the difference is of 2. So what happened that oxygen will gain the 2 electrons. That's why it will carry the O2 negative, because as we have seen in the case of the cations, when the 1 electron is removed, so the 1 positive charge is there, and the 2 electrons are removed, 2 positive, 3 electrons removed, 3 positive. So the same condition will be here, and the metals are forming the cations and the non-metals are forming the anions, because they are losing the electrons and they are gaining the electrons. And that's how student they are these metals are electropositive and the non-metals are electronegative. Fine. Now you'll see also that why they are like, what's the use of losing the electron, or what's the like what could be the advantage of gaining the electrons. We'll see all such things in the physical properties as well. Okay, but do you understand that what we have talked about the metals and non-metals, like their electropositive and electronegative nature? So that's how student metals are having the electropositive nature and the non-metals are having the electronegative nature because of the difference of gaining and losing of electrons. And how we are coming to that point, we have compared it with the what noble gases, and with the comparison we have seen that the non-metals are having more number of electrons in the outer shell, due to which they can't lose it, and that's why they just try to gain electron, and that's how non-metals are electronegative. Fine. Okay, now we are going to discuss about the physical properties of metals. So students, as we have seen, iron, copper, tin, so or aluminium, so all these are the metals exactly. And we have seen that even though in the formation of the bridges, and if we see any construction work, so the metals are, oh sorry, yes exactly, metals, or we can say that the iron rods are used for the structure of the buildings exactly. So what all these are made up of? They all are made up of metals only. Why we are using the metals in the buildings for the construction of any building? So that it will remain strong. That means we know this thing, that the metals are having the property that they are hard in nature and they have a high tensile strength. They are hard and have a high tensile strength. That means their strength is very, like you can say, very high. That's why we use these metals in the construction of bridges, so that they are not going to be destroyed anyhow, like within a, you can say, by just applying a physical force, or by the rainfall, they are not going to face such problem. That is why metals are used at the places where we need some hardness. Fine students, because of their high tensile strength. But students, we are having some exception here. Exception is what? That there are some metals, like it is sodium, that is the Na, and it is the potassium, that is the K, represented by capital K. So these two are the metals which are soft in nature. They are soft in nature that even though you can cut them with the help of knife. So that is the exception students, that okay, all of the metals, yes, they are very hard in nature and high tensile strength is there, but even though there are some metals like sodium and potassium, they are soft in nature, like even though you can cut them with the help of knife. Fine. All of the metals, like if we talk about iron box, copper wires, or even the aluminium sheets, so they all are solid at room temperature. They remain in the form of the solid, except mercury. Mercury is represented by He, and at the liquid, like they are a liquid at the room temperature. If you have noticed that we use the mercury in the thermometers, so in the thermometer students, what happened, there is the liquid of the mercury, exactly, like there is the filament of the mercury, and when we put that thermometer inside our mouth to check whether the temperature is normal or temperature is high, so what happened, when the temperature is high of our body, so what will happen, that the filament of the mercury increases towards the high temperature, and that's how we come to know that yes, we are suffering from fever. But if the temperature is normal, so it will remain at the room temperature only. Okay, so that's how student mercury is filled up in the thermometer as the filament, and that's why mercury exists in the liquid form at the room temperature. So again, it is the exception. Okay, Sonorous. So yes, metals are sonorous in nature. For example, if we talk about temples, like in temples we are having bells, like we just go and we just ring those bells. So how they are made up of? They are made up of iron only. That's, they are very strong in nature as well. So that means they are able to produce the sound, production of sound. Okay. Good conductor of heat and electricity. Yes, students, metals are good conductor of heat and electricity. How? Now I have to explain this thing. See, electricity is because of the current. Okay. And current is what? Current is the flow of electrons. Okay. It is the flow of electrons. When the electron starts flowing, so there is the current, and due to that current, electricity is generated. Now, students, as we have seen that the metals are losing their electrons, so when metals are losing their electrons, so that means they are having the free electrons. Okay. So what happened, that the metals are having free electrons. So these free electrons, when you have seen that when these electrons are present, free electrons, so they just start moving. And when they start moving, so there is the flow of current. And when the flow of current is there, so there is the electricity. And that is why we call them as the good conductor of heat and electricity. Fine. So that is why, student, we use the copper wires, like we use copper wires in our houses for the electricity purpose. Exactly. And if we talk about heat, like heat, so for example, student, that mm, what example should I give you? Okay, okay. Like at the one end you are having candle at this end, and here you are holding one iron rod, and you start heating it from this end. So after some time, student, what happened, that the other end, at the other end, you will start feeling heat. Why? Because the electrons are free and they are just moving here and there, due to which, student, there is a transfer of heat. And that's how the whole metal rod or the iron rod is getting heated. So that's how, student, due to the transfer of the heat, we can see that the metals are the good conductor of heat and electricity. Fine. Malleable. Malleable, that means they can be beaten into the sheets. Yes, we are having iron sheets, we are having, even though aluminium sheets we are having, and that aluminium sheet is used as the foil paper, like to wrap the food so that the food can remain fresh. Okay. Ductile. Yes, that means they can be drawn into the thin wires, as the copper wires we are using in our houses. Copper. Okay, so yes, they are ductile in nature. High melting point and boiling point. Yes, they are having high melting and boiling point, but except cesium and gallium, these two are the metals which are not having the high melting and boiling point. Now, why they are having high melting and boiling point, students? Because they are solid in nature. Okay. And when something is solid in nature, so what will happen, that their particles are very closely pegged. And when the particles are very closely pegged, so that means they are having more force of attraction. And when there is more force of attraction, so to melt any solid substance or to boil any substance, we have to give more heat. And when we are giving more heat, that means we are raising the temperature. And that's how, students, the metals are solid in nature. That's why they result into the high melting and boiling point. Fine. So these all are the physical properties of metals, but we have left one property, that is the lustrous. That the non-metals are lustrous in nature. That means they give shininess. For example, gold and silver. That means, student, they having the capability to reflect light. Fine, students. So these all are the physical properties of the metal. Okay. Now we are going to discuss about the physical properties of non-metals. So what happens, student, that non-metals can exist as solid as well as liquid and gases at room temperature. Like if I talk about gases, so gases are like oxygen, nitrogen. So these are the gases. If we talk about liquid, so bromine is one of those non-metal which exist in the form of the liquid at room temperature. Solid, if we talk about diamond is made up of, like the content of the diamond is made up, and carbon is what, student? It is a non-metal. And but due to the but as it is non-metal, still the diamond is solid in nature. If you have seen the diamond, so it is solid in nature, but you can say it is a non-metal. So you can say that it is the exception case, or we can say that the non-metals can exist three of these traits. But why the diamond is solid in nature? Because students, what happened that in the diamond there are so many number of carbon atoms, and these carbon atoms when combined together, so they form a giant structure, and due to that giant structure, students, the diamond will become very solid in nature and as well as hard also. Like the diamond, if we talk about, so that is also hard in nature, whereas students, the non-metals are generally soft in nature. For example, like sulfur powder, okay, oxygen, nitrogen gases, so they all are soft in nature. Brittle, that means they exist in the form of the powder form. For example, again we can take sulfur powder. Fine. Non-malleable, that means they can't draw into the sheets. Non-ductile, that means you can't draw them into the form of the wires. Non-sonorous, yes, they are not sonorous in nature, that from the sulfur, from oxygen or from nitrogen you are getting any sound. Exactly, no. So that's why they are non-sonorous. Bed conductors of heat and electricity, exactly student, they are the bed conductors of heat and electricity, or we can say that these are the insulators. So these are the insulators. Okay, so that means student, when the metals are when the non-metals are there, so they are the bed conductor of heat and electricity. Because students, what happened, if any person is getting shocked because of the electric current, okay, when electric current is there and the person is getting shocked because of it, so what you can do is you can take any wood log, and when you take a wood log, and if like there is the electric board and person is here, and if he is getting electric shock from that, because students, human being is a good conductor of electricity. Okay, so what happened when a person is getting electric shock and when you hit it with the help of wood, so what happens student, that wood is a bed conductor of the electricity. So when between these two wood is there, so wood will not allow the current to pass through the body of human. So that's how student, the we can say that the non-metals are the bed conductor of heat and electricity. Fine. Even the students, when you burn wood, so what happened, it convert into the ashes. Exactly, they are not getting like in the case of the iron rod we are getting the heat at the other end also, but in the case of the wood it converts into the ashes. Fine students, so that's the condition for the non-metals, that they are the bed conductors of heat and electricity. And even the students, that they are non-lustrous, that means they are not shiny in nature. But again there is one exception is what student, that the diamond is lustrous. Exactly, we know this thing, that the shine of the diamond, oh my god. So that's the exception here. Yes, I got one thing also, that for the conductivity there is the exception, that the graphite is again it is the carbon content only, but it is a good conductor of heat and no, but it is a good conductor of electricity because it is also having the one free electron. Fine, so these are the physical properties of the non-metal students. Okay, so that means we have discussed about the physical properties of metals, then we have discussed about the physical properties of non-metals. Now what is left, we are left with the exceptions. So as we can see here students, what are the exception? Alkali metals, so alkali metal students, that the basic metals you can say, sodium, potassium, and Li is the lithium, can be cut with using a knife. So this is the exception. Mercury is a liquid metal, we know this thing. Lead and mercury are the poor conductor of heat. Okay, mercury expands significantly for the slightest change in temperature. Like if, when you change the temperature very slightly also, so there is a change in mercury as well. Okay, gallium and cesium having a very low melting point, as we have discussed already. Iodine is a non-metal, but it has luster. Okay, it is also having luster, but the diamond is also having luster. Okay, graphite conducts electricity, as I have told you already. So these all are the exceptions students, which is lying in the metals and non-metals, and which we have already discussed. Now what we are going to see, some of the questions. So which of the following can be beaten into the sheets? So if we see that the beaten into the sheets is what? It is the ductility, and ductility is the property of what? That it is the property of the metals, because non-metals are non-ductile in nature. So if we see that among all of these, zinc is a metal, phosphorus, sulfur, and oxygen, these three are what? These three are Non-metals. So among all of these, which can be beaten into the sheet? So it is just zinc which can be beaten into the sheets. So the answer is zinc. Exactly, because zinc is metal with malleability and ductility, whereas phosphorus, sulfur, and oxygen are non-metals which lack malleability and ductility. Fine. Which of the following statement is correct? All metals are ductile, all non-metals are ductile. No, metals, non-metals are not ductile, they are non-ductile. Generally, metals are ductile, some non-metals are ductile. Metals are like non-metals, if we talk about any non-metal, so they are non-ductile in nature. But now the difference comes here, that whether all the metals are ductile or generally metals are ductile. Students, what happened is the sodium and potassium are very soft in nature, and even though they are very reactive, so we can't convert them into the sheets, like we can't beat them into the sheets. So that's a student, yes, metals are ductile, but all of the metals are not ductile, we can say. So generally this statement is correct, that generally metals are ductile. So yes, this answer is correct. Ductility is a property where substance can be drawn into thin wires. Oh, okay, okay, ductility is that. Oh, just a second. Fine. So it is the malleability we are talking about here. It happens sometimes, students. Don't worry, because I got confused between the ductility and the malleability. So it's the property of malleability. Fine, don't worry. Malleability and ductility. So yes, they are ductile. Now ductile is what? That a conversion into the thin wires. So into the thin wires, generally metals are ductile with the mercury as the exception. Like the mercury is liquid in nature, so we can't convert it into the thin sheets. That is why generally metals are ductile, but all of the metals are not ductile. Fine. So that's how, student, we have covered up all of the topics of this session, and I hope you got each and every point here, and I have given you very appropriate reason for each and everything as well. Okay, but if all, like, after watching this video at any point you are getting any question or any queries there, so what you can do, students, like you can post your question on the public or private forum of Ask IITians, and definitely you will get your answer from the expert side, and your queries will get resolved. Okay, and even though we have tried here to cover up all the things, but maybe if you are having any doubts, so definitely you can post it. Okay, because that forum is only for you students, so you should use it. Fine. So in the last, what I can say, thank you so much for watching this session, and keep learning from Ask IITians. Thank you.